Today's coal cutter loaders are powerful machines. A single unit may be rated at anything up to 500 horsepower. The only prime mover capable of supplying this sort of power in an efficient form is an electric motor. To power a machine like this, up to 400 kilowatts at 550 or 1100 volts is taken from switchgear and transformers situated at either end of the face. From these gate end boxes, the power is usually carried along the face by means of a trailing cable. On most longwall faces, there will be 200 meters or more of heavy screened cable to be handled in the wake of the machine. Whilst the machine is operating, at least one member of the face team must spend most of his time making sure that the cable is protected from damage.
Man the cable! Cable's caught! Good job!
Nevertheless, damage to cables still occurs. Whenever it happens, there is the risk of electrocution, gas ignition, and fire. Each year, the repair or replacement of trailing cables costs the NCB more than £15 million, and inevitably many times that figure in lost production. The Surepower distribution system eliminates the need for a trailing cable by employing a system of enclosed bus bars to supply power to the face. Surepower had its first underground trials in the South Midlands area. At South Leicester Colliery, M31's face was 50 metres long with an extracted thickness of just under 2 metres. The bus bars are enclosed in a robust steel duct, which is attached to an armoured face conveyor incorporating the rack-attract chainless haulage system. The Surepower distribution system is flexible within the design limits of the armoured face conveyor and the haulage system. In this installation, a flexible armoured hose supplies dust suppression water to the shearer. The top of the Surepower duct is sealed by means of 2 neoprene tubes. Current is collected from the enclosed bus bars through a separator unit, which moves with the machine and breaks the seal only at the point at which current is being taken. Mine atmosphere is drawn from the main gate through a filter, and after being checked for the presence of methane, is passed under pressure along the duct carrying the bus bars. During normal operation, pressure of air inside the duct ensures that along the length of the face, no methane, dust or water can enter. In practice, less than 10% of the airflow along the face has been lost through leakage from the system. At the end of the face, in the return gate, the airflow and pressure are monitored. Then the air passes through a simple non-return valve and is exhausted into the return roadway. If the blower unit is stopped, even for a short time, the potentially dangerous atmosphere along the face may have entered the duct. On restarting, the system is purged with filtered and monitored air equal in volume to 5 times the total volume of air contained in the duct along the face. If the monitors indicate all clear, the bus bars can be energized. The blower and filter unit which supplies air to the Surepower duct is mounted on the stage loader in the main gate. The blower unit delivers filtered air to a reservoir, at the entrance of which are 2 methane detectors. The reservoir capacity is large enough to ensure that contaminated air could not reach the face before the methane detectors cut off the power supply to the Surepower bus bars. The control and recording units collect information on the pressure, flow and condition of the air from both ends of the face. A telemetry interface allows information to be passed to a surface computer for online surveillance. At the Pitcraft Works, some of the equipment which will be used on the second Surepower face at South Leicester Colliery has been assembled in order to check clearances before it's installed underground. The trial equipment consists of about 15 metres of ducting from the main gate end, a shearer body, the Doughty roadhead support, and one of the Gullick-Dobson 240-ton 6-leg supports. After passing along the face, the air in the duct is returned to the mine atmosphere in the return gate. Behind the exhaust hood, there is a spring-loaded pressure plate which regulates the airflow through the duct and prevents air being blown in from outside in the event of back pressure from the return gate. If the air pressure or flow are too low, power is shut off. Inside the duct, the bus bars are in 2 sets of 5, 1 bus bar for each phase, and 1 each for the earth and pilot circuits. 2 sets can be accommodated within the duct, 1 on the face side and 1 on the gopher side. The Surepower duct is constructed of heavy gauge steel and is attached to the racker track and the armoured face conveyor. It is lined throughout its length with fire-resistant neoprene sheet to maintain an airtight seal across the flexible joints. The top of the duct consists of 2 neoprene tubes. Clamped together, these provide an effective seal, but are sufficiently flexible to allow a separator to pass along the duct and take current from the bus bars to power the shearer loader. The 2 sets of 5 bus bars are secured to a pair of steel housings by plastic insulators. The steel housings are shaped so as to form an earth screen between each phase bus bar. The top 3 bus bars on each side carry the power supply. The lower pair of bus bars on each side serve the earth and pilot circuits. 2 sets of bus bars are used so that 2 power loaders can operate independently. When power is being supplied to a moving machine, the current is picked up from the bus bars by a wheeled current collector. Spring-loaded brushes connect with the bus bars on one side of the duct. Although 2 current collectors can operate at the same time within the duct, they cannot, of course, pass each other. A flexibly mounted separator unit parts the sealing tubes at the top of the duct and connects the current collector to the power loader. Small particles of coal, which might become trapped between the tubes, are blown clear by air bleeding around the separator. The separator is specially shaped to clear its own path through any loose coal on top of the duct. The separator unit tows the current collector along the duct. There are 3 sets of spring-loaded brushes for each of the 3 phases, 2 for the earth bar and 1 for the pilot circuit. The current collector moves within the enclosure on nylon wheels, which engage at top and bottom with tracks formed as part of the bus bar housings. Each pan-length section of bus bar assembly is fitted with phase barriers to isolate each of the 3 phases. Within the barriers, the live bus bars are mounted on post insulators. The earth bus bar is connected directly to the steel housing. Sliding insulated connectors maintain a tight but flexible joint between each section. To ensure that an electrical connection is maintained during flexing of the joint, the ends of the bus bars and the connecting strips are louvered and silver-plated. Joints like this have undergone over 20,000 flexing movements with very little reduction in conductivity. Movement at the joints will take place as a result of variations in floor conditions and each time the face advances. Both the bus bars and the ducting are sectionalized into 1.5 meter lengths to match up with the armoured face conveyor pan lengths. This allows for elongation and articulation of the joints in order to accommodate uneven floor conditions and gives the flexibility required to snake over the face conveyor. The current collector successfully negotiated joints which had been deliberately flexed in excess of the design limitations of the racker track system. The equipment assembled here was installed on a second Surepower face at South Leicester Netherlands 9s, and production commenced in February 1980. The first 100,000 tons were cut and loaded in 21 weeks of production. The Surepower system of electrical supply continues the movement towards fully integrated mining systems,